Hello everyone, my name is Krati Gupta. I'm an assistant professor in Kite Group of Institution. In this video, we will be studying about the topic searching in data structure. The content which we will be covering in this video will be searching, different types of searching. Then we will be starting with the first type, that is linear search. We will be discussing about the implementation of algorithm of linear search in a linear search function. Then we will be studying about the analysis of linear search. Okay, so the first topic, first content is searching. uh, what is searching? Searching is an operation in which we find an element among the different s- uh, same type of elements. That is, for example, suppose we have a certain record. Suppose we are storing a record of students. Now we want to find a record of specified student. Suppose student name X. We need to find the record of that particular student which whose name is X. So among all the students data, we will be finding the data of student X. This process of finding, okay, is called as searching. When we are performing this finding, when we are applying this operation searching, then in that what we are doing, we are first uh, looking that whether this particular student X is present among these group of students or not in that particular record, whether the record of student X is present or not. And if the record of student X is found among all these group, then next we are locating the position, at which position that student X record is found. So searching is a process of finding the position of that particular element among several given element, and all these elements are of the same type. Okay, our search will be successful if the element record is found. And if the element is not found among the given several elements, then the search will be unsuccessful. Okay, so searching is what? Process of finding the element, and if the element is found, then it will be called as successful search, and if the element is not found, then it will be called as unsuccessful search. Now we have different methods with which we can perform the searching on the data. Okay, but these methods can be only applied if our data is organized in a particular way. We have several methods. Some of the methods are linear search, binary search, index based, sequential search. In this video we will be only studying about the linear search. In the upcoming video we have covered the topic binary search and index based search. So the first searching method is a linear search method. It is one of the simplest searching algorithm. As the name says, linear. Linear means in a line. So this search is done in a linear way only. That is, one by one we are comparing the element to be searched with all the record of data we have stored. Okay, so this type of linear searching can applied on any linear data structure. We can apply the linear search, whether it is array or linked list, we can apply the linear search method. So it basically what it does, it traverses the, if we are performing the linear search in an array, then it will be traversing the array sequentially to locate where the required element is. Required element is the element which we need to search. It will be comparing it, the element to be searched is compared with each and every element one by one in a array. As we are traversing one by one in a sequence, so it is also called as a sequential search. So linear search is the simplest one. It performs sequentially, due to which it is also called as a sequential search. Let's just discuss about the example. Suppose we have an array, and in array elements are stored 13, 48, 7, 4, 15, 25, 11. This is an array. And now we need to search element whose data is 15 within this array, whether this 15 is present in array or not, and if it is present, then at what location it is present. So what linear search will be doing, linear search will be comparing this element 15 with each and every element of this array one by one. So 15 is first compared with the first element, which is 13. 15 equal to 13? No, it is not equal to 13. So yes, it will uh, compare with the next element in a sequence. So second element is 48. 15 is compared with 48. 15 is not equals to 48, so again it will be compared with the next element. Next element is 7. 15 is compared with 7. 15 is not equal to 7, so again a comparison is made. Now 15 is compared with 4. 15 is not equals to 4. Again a comparison made. 15 equals to 15. Yes, 15 is equals to 15. So here our search will stop. Our search is successful. Why? Because element 15 is found in this particular data structure, in this array. And at what location it is found? At this particular index location of 15 this found. So this location would be returned. Okay, so linear search is one by one in a sequence. We are comparing the target element which is to be searched with all the elements in a data structure. Okay, so as it is performing one by one in one way, it is also called as a linear search. Now let us discuss the linear search function, how it is implemented. To perform the linear search, first data structure is required where a searching is needed to be performed. It can be array, it can be linked list also. You can perform the linear search operation in linked list also. So if we are performing in an array, we required an array, and this array is of size n, means this array arr contain n number of elements. Then next, what is required? The element which is to be searched in this particular array is required. So we have taken integer x. Integer x is an element which is needed to be searched in an array of n, which contain n number of elements. So as we are comparing all the elements of this array one by one, so we need a variable through which we can traverse the all the elements which are present in the array. So we have taken a variable I. This I is used for traversing all the elements. Now searching is done from starting to last till the element is found. So we have taken for a loop which is starting from which I equals to 0. Why? Because we are starting from the first element. We are comparing from the first element to the last element. So I less than n. Now for each element, what we are doing, we are comparing each element with x. For comparison, we have taken the comparative operator. Now we are checking whether the element at ith index location is equal to x or not. If this element is equal, then we are returning I. I is the index location where the element is matched. If the at particular index location I, if the element which is present in this particular position is equal to x, that means our search is successful and we are returning this particular index location I. And if suppose all the element does not match with any of the value in at any particular position, then we are returning -1. This, if the value returned by the function is -1, it means that search is unsuccessful. None of the element which are present in the array matched with the element which is to be searched. Element was not present in the array. Okay, so search is unsuccessful, which can be indicated by the value -1. Okay, and if any other value other than -1 is returned, then that means our search is successful and element x is found at location I in the array. So this is the implementation of a linear search. Next we will be discussing about analysis of linear search. In analysis of linear search, first is best case time complexity. Best case means which take minimum number of, with minimum number of comparison we were able to find the element. Our search was successful, we were able to find the element. So in linear search we are starting from the first element. So if the first element is the element which we were searching, then that will be what? Best case. So the element being searched may be found at the first position, so this will be the what, if it is found at the first position, then we will terminate the search, and number of comparison, total number of comparison which are required in that this particular case is only one. So the best case for linear search algorithm takes only constant operation. So best case is we go of one operation. Next is worst case time complexity. The worst case time complexity will be the maximum number of comparison that may be required to perform the linear search. The maximum number of comparison will be, if we are in linear search, what we are doing, we are comparing with each and every element one by one. So if we are comparing each and every element one by one, the maximum comparison can be total number of elements present in the array. That is n. N were the total number of elements we have taken in an array. So maximum element, worst case can be that whether the element was present, either the element was present in the last position, or maybe element was not at all present in the array. If element is present in the last position, then also we required to make n number of comparison. And suppose if the element was not at all present in the array, so when we will be able to say this when we have compared with each and every element, and now we are sure that yes, x is not present in an array. Why? Because we have compared with each and every element and none of the element matches with element x. So in both the case we need to make n number of comparison. Thus in worst case linear search algorithm will take big O of n operation, that is big O of n number of comparison. Okay, so this was the time complexity for linear search. Thank you. In the next video, we will be talking about the binary search, analysis of binary search, and the index sequential search. Thank you.